Good morning, students. Today we are going to continue the last session. In the last session, we started the assembler directives. Okay, now we started the topics called as a assembler directives. Okay, so let us go for that topic. So I hope you are realizing the concept. If you are having any doubts regarding the last class and the today's class also, so you raise the questions in the WhatsApp group. So I don't know whether you are realizing or not, but if you are having any doubts, definitely you can raise the questions in the WhatsApp group. Okay, let's go to the slides. Okay. So here, yeah, mm, in the last class we started with the segment and ENDS. Okay, now we started with the segment and ENDS. So one thing is, in the last class we took some my data segment, means we took a group of statements and we written that one between the segment and NS. Okay, now so that block is called as a logical segment. That block is called as a logical segment, means logically we are saying that those three statements, whatever the value 1, value 2 result variables we declared in the last class, those three statements as a one group. Okay, as one group. Okay, so I'll come to that point. Okay, just remember that one. Okay, so after that we have seen that db is nothing but the defined byte, dw is nothing but the defined word, dd is nothing but the defined double. Okay, now defined byte means defining the 8-bit variable, defining the 16-bit variable, defining the 32-bit variable. So if you want how we are declared, we have seen in the last class. So let us suppose I'm having the variable 1 I would like to declare uh, a 8-bit number, then I'm going to write like this. So this is the declaration of the 8-bit number. Okay, now declaration of the 8-bit number using the defined byte directive. If you want to declare the 16-bit number, then I'm simply taking the variable 2. I'm assuming that the my variable is a variable name is a variable 2. Sorry, I would like to define the dw, right? So I'm going to give the number some uh, 5436 Okay, now this is a 16-bit number. Let us suppose I would like to declare the 32-bit number. 32-bit number mean how many characters should be there? It should be the how many digits should be there? It should be the 8. 8 4 ja 32. Okay, 8 4 ja 32. I'm assuming it is a variable 3 and dd space. So for my convenient I'm taking the 1234h, but don't think that it is a number. Actually, yeah, of course it is a number, but in order to show that it is a 8-bit now 16 sorry 32-bit number, I just took this one. How many digits are there, numerical values? 1 2 3 4 5 6 8. So total 8 digits are there, numerical digits. So each digit is taking the 4-bit number. So 8 4 is 32. It is a 32-bit number. So this is a syntax for declaring the example. Okay, now otherwise you can take this example. Syntax means we are supposed to take the variable name, db, and a value. Okay, now like that we are supposed to take the syntax. It is a example for how to make use of the different types of data types which are going to be supported by the macro assembler. So how many data types which are supported by the macro assembler? Three data types. One is a defined byte, that is a 8-bit number, 16-bit number, 32-bit number. 8-bit number, 16-bit number, 32-bit number. Now let us go for the another one, that is nothing but EQ. So the next one is a EQ statement. Okay, EQ is used for defining the constants. Defining the constant. It is just like a macros in your C language. It is just like macros in your C language. Okay, in the C language we are having the macros now, means whenever we are using one constant throughout the program many times, then we are going to declare that one as a constant on the top of the program. On the top of the program, whenever you would like to change that constant, we can simply change that particular macro value so that it is going to be reflected wherever it is used in that particular program. Okay, now just like that we are having the EQ is nothing but equate, which is used for defining the constants. Defining the constants, syntax is same. Let us suppose I'm taking the variable. So I'm just taking my variable is a v1, and I am taking the EQ. EQ is nothing but equate, which is a directive, MASM directive, that is assembler directive. Now I'm going to declare this one as a 34h. Means by using this particular statement, by using the v1 EQ 34h statement, I'm asking the assembler that wherever you are seeing the v1 variable, replace this v1 with the 34h data. Replace this particular v1 with the 34h data. So that is the means the EQ statement is used for declaring the constants. One, just declare that one on the top of the set and make use of the v1 name wherever you want, and so that you can easily replace that value if at all any changes are there in the future when you are trying to execute the program. So EQ is for defining the constants, okay. So the next one is the I'll come back to the assume later, because the assume is going to be followed in the program. Okay, so let me take the label. Let me take the label. What exactly the label? So here, when I'm going for defining the label, I would like to define three parameters. One is a register, okay, another one is a variable, and another one is a label. Another one is a label. Okay, so let me define three variables. Another one is a label. Okay, so what exactly the register? What exactly the register is the question. So register is nothing but it is a name assigned to a memory location. Register is nothing but it is a name assigned to a memory location. Similar to that, variable is also same. Okay, now variable is nothing but it is a name assigned to a memory location whose value may changes during the execution of the program. Register is also same. So register, variable, these two are the interchangeable words. Okay, so register is nothing when to use the register name and when to use the variable means when we are going for a particular architecture diagram, then there are some parameters, some variables al, ah, ax, ch, cl. So we can call them as the variables, but as they are specific to the architecture, they are not going to change. Their names are not going to be changed. So that's why they are called as a register. And the register intention is, register is nothing but it is a name assigned to a memory location, because whatever the register, let us suppose I'm having the accumulator al, I'm having the accumulator al. So whenever I'm using the variable al in the program, don't think that al is going to be recognized by your microprocessor. Actually, al is mapped to a memory location. So means wherever the AL is observed by the assembler, that AL is going to be replaced with its equivalent address. But that AL is going to be replaced with its equivalent address that is there in the form of the opcode. That is there in the form of the opcode. Means whatever the registers which are there, whatever the microprocessor it is, whether it is the 8085, 8086, or some other advanced microprocessor like 803, 86286, and Pentium, all those things, wherever you are having the register, register is nothing but it is a name assigned to a memory location. So memory location means we are having the registers now. For each register there is a memory location. So as a human beings, we are unable to remember the addresses of those memory locations. That's why what they have done is they predefined the what is that addresses in one order, and they assigned the name to a particular address. Means AL is having so and so address, H is having so and so address, BL is having so and so address. Means there are some addresses and we can't remember those addresses. Because of that, what they have done is they have given the naming conventions to that particular address. They are the fixed addresses. They are the fixed addresses. Means AL address is not going to be changed, BL address is not going to be changed, AH address is not going to be changed, AH address is not going to be changed, BH address is not going to be changed, BX address is not going to be changed, CX address is not going to be changed. They are the fixed addresses, but in order to make use of those addresses, means in order to allow the developer and user to access those addresses directly, they are given the naming conventions. They are given the naming convention. So that is why the register is nothing but it is a name assigned to a memory location whose value may changes during the execution of the program. You can note it down the statement. Register is nothing but it is a name assigned to a memory location whose value may changes during the execution of the program. And remember, whatever the register names we are having, they are having the fixed addresses. Now, when you are coming back to the variable, variable is also name assigned to a memory location whose value may changes during the execution of the program. Whose value changes may changes during the execution of the program. Now the question is, what is the difference between the register and the variable? So variable is a name assigned to a memory location. That memory location may changes. It is not the fixed one. Means let us suppose I'm taking the AL register. For example, if I'm taking the AL register, then I'm assuming that it is a 30H address. I'm just assuming that AL is assigned with the 30H address. So it is going to be fixed one. But if you are declaring the variable, if you are declaring the variable like this, so in the last class we have seen, so I'm having the v1, sorry, I'm having the let me take this right, and yeah, I'm having the v1 and followed by db followed by 06h. So in this case, after writing your program, you are executing the program. For example, you are executing the program where we are having v1 variable. Then this v1 variable is holding the 06h. This v1 variable is having some address, means it is a name assigned to a memory location. Let us suppose I'm assuming this address v1 is equals to the means it is assigned with the 60h first time. Okay, let us suppose second time, after executing the program for the first time, you got the I'm assuming that v1 is the name assigned to a memory location which is a 60h. Second time, let us suppose you are re-executing this program, you are re-executing this same program. At that time, v1 address is not going to be the 60h. v1 address is not going to be the 60h. It may be some other value. It may be some other value. Means let us suppose I am assuming it is a this time v1 is assigned with the 90h. So means the variables which are used, the temporary variables which are used in your program, they are not having the fixed addresses. On every execution there are separate addresses, means the address is going to be changing. But whatever the address it is, in order to access that particular address, for the human being convenient, we are taking the variable name. Means during the runtime, the microprocessor is the one, that is the assembler, whatever the assembler or the compiler which you are using, that takes the responsibility to map your variable name to a particular memory location. Okay, now to map your variable name to a particular memory location. But if you come to the registers case, the registers addresses are not going to be changes. They are the fixed one. They are fixed and they are having the predefined names, and that is done by the manufacturer. Let us suppose 8086 microprocessor manufacturer, which is an Intel manufacturer. Let us suppose Intel manufacturer is not only the Intel, whoever the manufacturer it is. If you are taking the 8086 microprocessor, they are having the predefined addresses to a particular register, and those addresses are not going to be changes. That is the difference between the register and variable. Means register addresses are the fixed one, but the register is a name assigned to a memory location. Variable addresses are the changed one. They are not the fixed one, but they are also named as variable is nothing but it is a name assigned to a memory location. Okay, now it is a name assigned to a memory location whose value may changes during the execution of the program. Okay, now for your convenient, if you want, you can define that one, register or variable. Okay, now both the statement is same, but if someone is asking more specific, what is the difference between the register and variable? Register name addresses are fixed. Registers are nothing but it is a name assigned to a memory location whose address is a fixed one and whose value may changes during the execution of the program. Variable is nothing but it is a name assigned to a memory location whose value may changes during the execution of the program, and this variable address is not the fixed one. Okay, now on every execution, wherever the space is empty, there your program is going to be executed. At that time, we are having the separate addresses, not the fixed addresses. Okay, so that is a variable. Next case is a label. So label is nothing but it is also name assigned to a memory location for the reference point of view. It is not the it is a memory location only, but it is not used for holding the values. Okay, it is not used for holding the values. For example, in the previous classes, we would have taken one program. I'm simply taking one simple program, move move al comma, even though it is taking time, no problem, we'll take off this one. So I'll take the add instruction directly, add space al comma 06h. Means I would like to add the 03 with the 06h continuously with the JMP instruction. We have seen the JMP now, so I'm just assuming the label name is a L1. Name is a L1. Now I would like to repeat this addition infinite times. I'm just doing some unnecessary thing. We are not supposed to do like this, but I'm just doing an unnecessary thing. Okay, in order to explain the label. Okay, in order to explain the label. At that time, what I'm going to do, I'm going to make use of the L1 over here. I'm going to take the L1 column. Okay, I'm going to take the L1 column. So means JMP L1. Here the L1 is called as a label. Okay, this label, what is the difference between the register variable label that I would like to define? Label is nothing but it is a name assigned to a memory location. That's it. It is not holding any kind of value. It is a reference point where to jump. Where to jump. It is a reference point. Actually, if you go more specific, actually L1 is holding the displacement value. If you go more specific, it is holding the displacement value. But in order to avoid the confusion, what exactly the displacement, all those things, you just remember that L1 is nothing but it is a name assigned to a memory location which is used for reference point. Means here JMP L1 means I am asking the assembler when take the L1 and jumps to the specific memory location. Means L1 is nothing but it is a name assigned to a memory location where exactly the add instruction is stored. Where exactly the add instruction is stored. Okay, so that is actually, if you go other way, it is different one, but for your convenience I am saying that L1 is holding the it is a name assigned to a memory location. In simple statement, it is a name assigned to a memory location, but it is not trying to hold any kind of values. It is only for reference point to where to jump, where to jump. So that is what the label. Okay, we are having the register variable label. Register is nothing but it is a name assigned to a memory location whose value may changes during the execution of the program, and the name which is assigned to a memory location which is a fixed one. But in case of the variable, variable is nothing but it is a name assigned to a memory location whose value may changes during the execution of the program, and the addresses which are assigned to the names, or the names which are mapped to the addresses, they are not the fixed one, they are the changed one. Now if you go to the label, label is nothing but it is a name assigned to a memory location which is acting as a reference value, means where to jump. If you go more specific, it is a displacement value. Actually it is a displacement value. Here or somewhere we will come across that particular displacement also. At that time we will go in detail. Okay, we will go in detail. Now let's go to the yeah, I'm done with this one now. So let's go to the assume, the next case. Let's go to the assume. Sorry, no. Let's go to the assume. Okay, so let's go to the assume. Okay, so let me come back. Use assume. Okay, what exactly the assume? Okay, what exactly the assume? So in the last class we started with something, right? In the last class we started with something, right? We started with something, right? In the last class we started with something. That is nothing but my data. Okay, my data, space segment. Yeah, we took the segment, right? Okay, I'll rewrite this one. My data. Okay, so what is the our program? We started in the last class to perform the addition of two numbers. We have done normal way. Another way is using the MASM assembler, how to write the program to perform the addition of two numbers. So I'm just taking I'm declaring the variables my data. I'm declaring the variables my data segment. My data segment. Okay, segment. I'll take the blue man. Sorry, I'll take the blue. Okay, my data segment. Okay, so here what I'm going to do is I'm supposed to declare the variables, right? I'm supposed to declare the variables. So v1 db. I'm not taking the separate color code. 03. I think in the last class I took some values. I didn't remember that, so I'm just taking the another values. So yeah, in the last class we took the value one, right? Okay, so value 1 db 03h space value 2 db 06h, enter. We took another variable result. Okay, result. I'm not going to repeat this one, you just note it this program. Okay, again we are make use of this one. So here we are supposed to terminate with ENDS, and it should be preceded with the my data. It should be preceded with the my data, right? Preceded with the my data. Okay, it should be preceded with the my data. Look at this one. So here we are writing a set of statements. We are writing a set of statements which is a declaration of the variables. We are writing a set of statements which is a declaration of the variables, and these statements are written between the segment and ENDS. Whenever we are using the two directives, segment and ENDS, at that time the assembler is going to be treat these statements as a one group. These statements as a one group, they are called as a logical segment. They are commonly called as a, means this entire thing is called as a logical segment. This entire thing is called as a logical segment. Okay, now to this particular logical segment, means I'm having a group. Now I need to take the reference, means where exactly this particular segment is started, means I need to know the starting address of my segment. I define one logical segment. This is a logical segment. I define one logical segment with the help of the segment and ENDS directives, and I need to know the starting address of that particular segment, right? I need to know the starting address of that particular segment. So that is going to be indicated by the my data. Means my data is nothing but it is a label. My data is nothing but it is not a name. It is a name assigned to a memory location which is indicating the starting address of your segment. So I can call the my data as a label. I can call my data as a label, means I'm using the my data label to refer the starting address of my segment. And also this label here explicitly we are indicating that this label is ended at the ENDS. Okay, so my data is a name. Why I came back to this particular statement, I'll explain that one. So because I just gone with the assume, I would like to explain the assume. So here what is our statement? We took the my data, means we declared the variables, and this is a logical segment. Now I'm assuming that it is related to the data, so obviously I'm assuming this one is a data segment. This logical segment is a data segment. That's why I gave the my valid name called as a my data. So I'm assuming this is a what is that, data segment. After that, what I'm going to do means we need to perform the addition, right? We need to perform the addition. So I'm going to take another name, my code, because the whatever the program which we are writing, it should be there in the code segment, right? Program operation should be there in the code segment, data should be there in the data segment. So I'm just taking the segment. I'm just taking the segment, right? So segment, why I'm using the segment? Why I'm using the segment? Again, in order to show that where exactly the my code segment is started. In order to show that, means in order to write the addition of the program and group them as a one segment and call them as a call that particular group as a logical segment, which is nothing but the code segment. I just use the segment. Okay. After that, what I'm going to do is here in the segment case, under the segment, whenever you are writing the code, whenever you are writing the actual program, means declaration of the variable is in the data segment, declaration of the variables in the data segment, and writing the program is should be there in the code segment. Before starting the actual code, before starting the actual code, you are supposed to inform the assembler, macro assembler. Explicitly, you are supposed to inform the macro assembler that where exactly, means what is your data segment, what is your data segment, and what is your code segment, means which one you treated as a code segment, which one you treated as a data segment. You should explicitly mention that information to the microprocessor via that information to the macro assembler, that information to the macro assembler. Further, what I'm going to do means I'm going to make use of the assume. This particular assume means I'm going to use soon after you started the code segment. Soon after you started the code segment with the segment directive, you are supposed to make use of assume. You are supposed to make use of the assume. Assume is nothing but where with the help of the assume we are explicitly asking the microprocessor, asking the assembler which one we are treating as a code segment, which one we are treating as a data segment. So here it is not going to be very useful. I'm just shifting this information to the left side because it is going to be extended. Okay, so where exactly you are doing. So I'm just performing the my code. I'm just starting the my code segment, means code segment, and after that, as I said, I'm going to make use of the assume. I'm going to make use of the assume. What is the intention of the assume? Intention of the assume is to inform the assembler which logical segment should be treated as a code segment, which logical segment should be treated as a data segment. So with the help of the assume directive, assume space CS. Actual code segment is nothing but what? CS. Code segment is nothing but the CS colon. Code segment is started from where ma? Started from this particular point na? So I assign the name, that is the label name, which is nothing but the my code. So my code is a label name assigned to a one logical segment. I am treating that logical segment as a code segment. So here I am going to explicitly mention that one. I am going to explicitly mention that one by writing my code. By writing my code. Okay, now by writing my code. Okay, comma. You are supposed to mention the data segment also now, because your program depends on the data also. You are supposed to mention the data segment now. So for that, what I'm going to do means I'm going to again I need to explicitly mention that my code. See, it is a one statement ma. Assume CS colon my code comma continuation. Actually, I took the next line because of the space. I think my okay. I'll explain the assume. You just note down this one. You just note down this one, because here my photograph is going to be opposite display. So what I'll do is I'm just shifting this one to the left side. Actually, it is a continuation to this one. Just remember. So it is a DS colon. So means I'm asking the assembler treat the my data as a data segment. Okay, now with the help of the ds colon my data means I'm asking the assembler treat the my data. I'm asking the assembler treat the my data label as a data segment. My data label as a data segment. Okay, now. So what is the intention of the assume? Assume intention is the assume directive is used by the developer to inform the assembler saying that which logical segment should be treated as a code segment, which logical segment should be treated as a data segment, which logical segment should be treated as an extra segment. Okay now. So in order to mention that one, in order to inform that information, okay now, we are using the assume directive. With the help of the assume directive, we are asking the macro assembler which statement should be which logical segment should be treated as a code segment, which logical segment should be treated as a data segment. Okay now. So if you are having the extra segment, you are supposed to use the comma and the es colon my extra, like that. Means whatever the name you are assigning to a particular logical segment, whatever the name you are assigning to a particular logical segment. Okay now. So this is the assume intention. Assume means we are you making use of the assume to inform the assembler that which segment is used as a data declared or we treat it as a data segment and the code segment. In order to inform that information to the assembler explicitly, we are using the assume directive. We are using the assume directive. I'll continue the addition program. So till this point, you just remember, because the space is not sufficient. Whatever the screen which we are seeing, it is not sufficient. Okay. So I'll come back to that one. I'll come back to that program. So we already started. So I'm not going. I'm sorry. We already started the program. I'm not going to use the my data again. I'm going to continue with the code segment. Okay. So the next one is the END. What is the use of the END? Is a question. So END directive is used for terminating the program. Okay. And using the END directive, we are informing the assembler that whatever the statements which are written after the END directive, don't treat them as a part of your program. Don't treat them as part of your program. Okay, now explicitly we are mentioning that. Okay, so means END directive is used for indicating the termination of the program to the assembler. Okay, now see ma, these directives are used for talking to the assembler. Where means the developer is talking to the assembler in a proper way. Okay, so we are having the remaining also. I'll come back to that one. We'll finish off our addition program first. Okay, we'll finish off our addition program. We declared the two variables, value 1, value 2, and we declared the one more third variable, which is the result, to hold the result. Okay, so I hope you remembered that segment. And now I'm going to write the code segment, means actual operation, addition operation, which is performed. Okay, so here what I'm going to do is, mm, yeah, I need to start the code segment, right? I'll take the code segment. So my code segment. So I need to write the assume, right? As I said, I need to write the assume. Otherwise, I'll take the fresh copy. I'll take the fresh copy. My code. My code segment. I need to write assume, right? Assume. Assume colon. So treat the my code segment as a code segment. My code label as a code segment. My code, comma. Actually, it is a continuation. Again, we don't have the sufficient space, so that's why I'm using the next line. We declared the we need the data segment now, so I'm just taking set ds colon my data. We declared that one as a my data now, right? My data, my data. So it means asking that my code, you use the my code label as a code segment, my data label as a data segment. After that, what we are supposed to do? We are supposed to start our program. So in order to indicate the actual code starting point, we are using one name, one directive called as a start. One directive called as a start colon, means we are saying to the assembler that from where exactly our code is started, actual code is started. So here the data is there in the my what is that logical segment na, which is there in the my data na. So my data is a, as we know that my data is a label name, right? It is a name assigned to a memory location. So in order to run your program, in order to map this particular logical segment into the data segment, what you are supposed to do means, my data is nothing but it is a label now, it is a name assigned to a memory location now. This memory location address, this memory location which is referred by the my data should be loaded into the ds, so that from there your data segment is going to be start. From there your data segment is going to be start. Okay, so because of that, in order to read the my data address, means my data is a name assigned to a address na. So in order to read the my data address to the ds, it is not the direct one, it should be done by the accumulator. Means I'm going to make use of the accumulator over here. I'm simply writing the move x comma my data, x comma my data, means my data is a name assigned to a memory location. That address is going to be copied into the ax. Now from the ax we are supposed to load into the ds comma ax. I hope you are realizing the concept. Okay, my data is a name assigned to a memory location, which is a logical segment. Starting point of the logical segment, which is a data segment, is referred with the my data. So with the help of the my data segment, we are supposed to give the starting address of the data segment into the data segment register now, because it is holding the base address of our data segment, right? So for that, I'm taking the base address of my logical segment, which is declared as a data segment, into the AX, from the AX into the DS. Now the DS is holding the starting address of the data segment. Okay, now starting address of the data segment, which was named as a my data. Okay, so in the next case, what we are supposed to do means we are supposed to perform the addition operation. Our intention is performing the addition operation, right? Performing the addition operation. I think the space is not sufficient. Okay, so once you set the starting address of the ds, that is the data segment, then we are having the two variables. Now we are supposed to take one variable, so each variable is a 8-bit number. So I'm just taking the variable value, because in order to perform the addition you are supposed to take that one into the segment, you are supposed to take that one into one of the internal register. I'm just taking al comma value 1, al comma value 1. it is saying that value 1, I think in the today's video, I think I took the 03 and value 2 is a 06, right? 03 means by this statement AL is filled with the 03. Okay, now another variable, another value is what? 06. So if you want, you can make use of that one directly over here. Okay, now so I took the value 1 over here and the value 2. Yeah, I need to perform the addition, right? Add AL comma value 2. Value 1 is stored in the AL and value 2 is directly added with the AL value, and we are having the result in the AL now. So I would like to read this AL value result which is there in the AL into the result variable which is declared in the data segment. So I'm going to write move space result, move space result comma AL. So by this statement we successfully copying the result of the addition into the result variable which is there in the data segment. Result variable which is there in the data segment. Okay. So the now what I'm going to do is I need to write the termination of the program. Termination of the program is nothing but what? int03h. Termination of the program is nothing but int03h. So as the screen is not sufficient, what I'm going to do is I'm going to use the separate color code. So use that particular separate color code, whatever the instructions I'm going to write using the separate color code as a continuation to this particular program. Continuation means the next statement is that one. Okay, so I'm just taking the red mark, so I'm not going to do repeat this kind of a problem in the future. Okay, so just remember after int03h what we are supposed to do, we are supposed to terminate our code segment now. We are supposed to terminate our code segment, so that's why I'm simply typing we are supposed to terminate the code segment. So segment, logical segment should be terminated with what? Logical segment should be terminated with the ENDS. Okay, now logical segment is terminated with the ENDS means segment is started over here and it is followed like this and terminated over here. Okay, now terminated over here. So this one is a termination of the code segment, but we should end the program now. We should end the program as per the assembler instructions. So actually the termination of the program is over here only. It is done with the int03h. With the int03h program termination is over. But as we are using the macro assembler, we are having certain rules and regulations how to indicate the termination of the program, because if you are not indicating the termination of your program to the assembler, not to the microprocessor, to the assembler, then definitely it is not going to be realized where exactly your code segment is terminated, so we are indicating explicitly that the code segment is terminated, which is a my code ANDS. It should be used after the int03h now. Again I am repeating, it should be used after the int03h. Whatever the statement I am writing in the red color, they should be in the after these statements. Okay, now in the order. Okay, now after the int03h you should take in the down format. After that you should terminate the program now. So for that you are supposed to write like this. So means I'm going to use the END directive to terminate, and which one is terminating? Started one is terminating. So ENDS space, sorry, END, it is not the ENDS for segment termination, END for what is that, uh, assembler termination means we are asking the assembler after the END statement whatever the instructions are there, they are not the part of your program. In order to explicitly mention that information to the assembler, we are using the end start means we are terminating the started code segment. We terminating the started code segment means wherever the end END segment seen by the microprocessor, sorry, assembler, it is realizing that up to this point the statements are as a part of our program, and after that whatever the statements are there, they are not going to be executed by the assembler. Okay, so this is all about how to write the program using the MASM assembler for a particular MASM assembler. Okay, now so we declared the three variables in the code segment. In the data segment, in the code segment we started the one logical segment which is named as a my code, and here we used the assume. Why we are used, I think I just note down this entire thing. Okay, you just note down this entire thing. I think wait a minute. Yeah, it is exceeding, the video is exceeding, video is also exceeding. I'll take one simple scenario for the explanation point of view, because I'm not satisfied with this. So up to END, we are having the few more directives also, but I like to show the program, the complete format. I'm not satisfied with what I have shown you. Okay, so I'm just taking my data. I'll go with the first one. Don't worry. Same thing. If you are not interested, you can terminate the process. But as I missed out something, I'm not satisfied with what I explained, because one window means it is not the good one. My data. So after that, I need to go with the value one, value one, value one space db, value one space db, 03h. I declared the 03h today. Just taking some, okay, 03h. After that, value 2 db 06h, and we declared the result variable result, and I initialized this one with 00h, some initial value, in order to avoid the garbage. I'm terminating my data segment. I'm terminating my data segment with the my data segment, and termination of the segment should be indicated with the ENDS. Termination of the segment should be indicated with the ENDS. With this, data segment is over. Then immediately I'm going to start the my code segment, followed by assume. I need to make use of the assume. So with the help of the assume, I'm explicitly mentioning that from where exactly the code segment is started, which logical segment should be treated as a code segment. What is the code segment for this one? My code. So my code logical segment should be treated as a code segment, comma, ds my colon, okay, sorry, my data should be treated as a data segment. My data should be treated as a data segment. Done with this. So we should start actual code, right? I'm just taking the start option. After that, I'm going to write, means we need to take the reference. So my data is a label name. It is a label, actually it is a name assigned to the starting address of our data segment. So that particular starting address should be saved in the data segment register. Okay, now data segment register. So that's why I'm taking this value into the AX register. Means AX is filled with the starting address of the my data segment, and this value, this starting address should be saved into the DS register, so that it is going to be treated as a data segment. DS register. It should be done via the accumulator. You can't copy some data directly to the segment registers, as we have seen in the during the instruction set. After that, I'm taking the value one. So here we are having the value one now. Value one is I'm taking the value one into the AL register. I'm taking the value one into the AL register because it is a 8-bit number. So I'm just taking the AL register value one. Okay. Now, so if you want, you can directly perform the addition with the value 2. Otherwise, you can take the value 2 into some other internal register. Move value 2. I'm just taking the value 2 into one more register. If you want more specific way, value 2. Okay. And after that, I'm performing the addition. Add AL comma BL, means value 1, value 2 are added, and result should be saved in the into which one result variable, because result variable is there in the data segment. Okay, now I would like to store back my result into the data segment. So move a result, fill the result with the AL register. Okay, now result the AL register. After that, what we are supposed to do? We are supposed to terminate the program. I'm using the int03h for terminating the program. For terminating the program, I'm using the int03h. After that, what we are supposed to do? We terminated the int. Yeah. After that, we are supposed to terminate our code segment. My code. So with the help of the ENDS, my code with the help of the my code with the help of the ENDS segment. Means explicitly we are mentioning that code segment is started over here, code segment is started over here, and code segment is ended over here. But we started the actual code with the help of the start label now. So I'm going to terminate the start also. So let us suppose END space start. So start is terminated. Now after the end directive, if I'm writing any statements, let us suppose add or subtract something, whatever the statement which I'm going to use after this one, after end statement, if I'm using this I'm writing some instructions, a group of instructions, those won't be executed by your assembler, because with the help of the end directive, you are informing the assembler that up to this point only you should execute the program. Means you should convert your program into the executable file, from there to the binary file, and execute them. Okay, now like that, we are informing to the assembler with the help of the end directive to terminate the program. So means after the end directive, if you are having any instructions, whatever the instructions you are having after this one, those instructions not going to be executed by your assembler. So this is a simple statement, a simple explanation of how to write the program for a macro assembler. How to write the program for a macro assembler? Rules are nothing but, first you should define the logical segments, and which segment you are treating as a code segment and which segment you are treating as a data segment. That should be explicitly mentioned with help of the assume statement. With the help of the assume statement. Okay, with the help of the assume directive. Okay, so this is all about our what is that? Some program writing the some addition program, addition program for particular macro assembler. Okay, okay. So next we left with the proc, END, all those things. We will continue in the next class. In the next class, definitely we are going to finish up this, because today's class I took some example. Okay, so that's why I took more time. So in the next class we are going to finish up the assembler directives. Okay, thanks for means that's all for today's class. If you are having any queries regarding the this class, then you can ask me.